All right, guys, today we're going to talk about rectangles. So the most important thing here is the fact that a rectangle is a parallelogram, okay? I can't emphasize that enough. That means all the properties we've already learned about parallelograms apply to rectangles, okay? But there's these two new facts, right? The first one being here, the defining characteristic of a rectangle. So what makes a parallelogram a rectangle? All four angles are congruent, and because they have to have the 360, that means specifically they're all 90 degrees. So I end up with four right angles here. All right. The second one being that the diagonals are congruent. So if we talk about the diagonals being congruent, there's a couple neat things here. Because they are congruent and because they're a parallelogram, they also bisect each other. That means all four of these segments here are congruent, right? So if we go ahead and label this, we can talk about it. We've got A, B, C, D, right? What we can see here is going to happen is we still have opposite sides are congruent and parallel. It's a parallelogram, right? But now we also have these other segments in the middle, AP, BP, CP, and DP, that are all congruent, all right? So the diagonals are congruent. Let's go ahead and fill that in here. We know that AC is congruent to DB, right? But we also know that because of that, we're going to have AP is congruent to BP, is congruent to CP, is congruent to DP, right? So all four of those segments are congruent as well because of the fact that parallelograms, the diagonals bisect each other, and in rectangles, they are congruent, all right? Now, if we take a look here, what does that make each of these triangles? Well, if we take a look here, this triangle is going to be isosceles, right? Triangle BPC. This triangle APD is also going to be isosceles, right? And furthermore, by side, those two are congruent. So let's take a look at that down here with this picture and how that works. Like I said, let's switch colors here. This triangle is isosceles, and it's congruent to this triangle, which is isosceles, okay? So what does that tell me? Whatever this angle is has to be congruent to that angle because it's isosceles. Because they're congruent triangles, that means that these two angles must be congruent. So all four of those angles are congruent. Furthermore, we can go ahead and take a look at the angles for this green one, right? We know that this triangle is going to be isosceles, and it's going to be congruent to this triangle, which is isosceles. So we know that this angle is going to be congruent to this angle, is going to be congruent to this angle, is going to be congruent to this angle. And then furthermore, we know in the middle we have our vertical angles. So 1, 2, 3, congruent to 1, 2, 3, and then 1, 2, 3, 4, congruent to 1, 2, 3, 4, all right? So there's a lot going on here with segments and with angles in a rectangle. One of my favorite types of problems is where I give you one angle of a rectangle and you have to find all the other angles, right? Every other single angle in there. Just kind of walk you through an example like that. Well, you know what? We'll save that for when I get back. You'll see it on the homework, all right? So these are the properties of a rectangle. You want to go ahead and update your foldable. Feel free to add some additional information if you want as far as angle DAB, ABC, BCD, and CDA, all being right angles. But in general, that's it. Go ahead and complete the assignment on Canvas. Email me early and often if you have questions, and just apply this information like we have been with parallelograms. You guys got this. Good luck. Bye.